Let's look at cubics a little bit closer. The formula for the perfect cube, we know the one for the perfect square, we should know the perfect cube one as well. It comes up a lot. A cubed plus 3a squared b plus 3ab squared plus b cubed has beautiful symmetry about it. 1, 3, 3, 1. Look at the powers. Starts at 3, powers go down by 1 on the a's, up by 1 by the b's. They always add up to be 3. Lovely little pattern. So that's a plus b all cubed. Minus is a similar thing, but the signs alternate. So you start with positive, negative, positive, negative. In fact, to generalise, if you want to expand out anything cubed, you will always get every term cubed 3 times where you grab one of the pronumerals twice, so it becomes squared, and another pronumeral. So you would get a squared b, you would get a squared c, you would get a squared d, however many there are. Then you would get a b squared c, b squared d, b, and so on and so on and so on. So all the ones where one of the pronumerals is squared and 1. And then when it comes to just grabbing one of the pronumerals at a time, you'll always get 6 of them. So you get 6 ABC. If there was more pronumerals there, you'd also get 6 ABD, 6 ABE. Every possible way of arranging 3 of the letters. That pattern is always there. How useful is that? How often would that sort of thing come up? Very rarely, but hey, it's good to know. Going the other way, factorising, difference of 2 cubes. This is why we start with the minus. Okay, because you always start with the little one bit first. So the a minus b, it's a difference of 2 cubes, so I start with the difference of the 2 pronumerals. In the second parentheses, again, there's the pattern. Start with the a squared, power of goes down by 1, power of b goes up by 1, always adds to 2 in this case. If in the first one it's a negative, then all the signs in the second one will be positive. The sum of 2 cubes, other way around, it starts with the positive, therefore in the second one it's negative, but it's only the middle term that is negative. See, we have a sum of 2 cubes. We don't have a sum of 2 squares. And there is a reason for that. We'll get to it via our examples. So, expanding out 2a minus 5 cubed. Once again, you might not write all that out, but that's the pattern. There's the 1, 3, 3, 1. Powers going down by 1, powers going up by 1, and so on. Expand it all out, there is our answer. Factorising. Oh, it's the sum of 2 cubes. I've got x cubed and 2 cubed. Again, you wouldn't necessarily write x cubed plus 2 cubed. So therefore, x plus 2, x squared minus 2x plus 4. Be very, very careful. It would be so easy to write minus 4x there because we're so used to writing twice the product in the middle there with quadratics. But it's not, because if you did put that, then the second one would factorise again and it would be something completely different. Y cubed minus 27a cubed, difference of 2 cubes. That one's y cubed minus 3a all cubed. So it starts with the minus, that means in the second one they're all positive. There it is, generalising it. If you have a to the power of anything minus b to the power of anything, it will always start with a minus b. So again, that's why in the difference of 2 squares, technically you should start with a minus b. Then in the second one, you start with the first pronumeral, powers go down by 1, b, powers goes up by 1, and you keep going all the way along. If we have x to the power of 5 minus y to the power of 5, it starts off x minus y, powers of x start going down by 1, so we're at the 4, then we keep going down by 1, y up by 1, 2 powers, always had to give 4 in this case. We have sum when it's odd. Even powers won't work. You will work with odd because you could always do that. You could always pull out a negative factor and make that negative 1 to the power of 7. You see, that doesn't work with the negative, because if you have an even power, that negative 1 to the power of 6, you can't pull it out, because it's a positive number. So technically, I'm looking at a difference there. So it becomes, what the effect it has, don't worry, you don't need that first line, because all the effect is, the signs alternate in the second one. That's all the effect it has. So I'll get a plus 1, I'll start with the plus. Powers of A go down by 1, powers of B, powers of the 1 go up by 1, and we alternate plus minus, plus minus, plus minus, plus minus, plus minus. until we get to the end. So from the old Cambridge, we'll try those.